Hello everyone, welcome back to the channel. Today we are going to look at how to view your seismic in your interpretation window and explain the concept of the interpretation window. So in the previous episode we looked at how to display your seismic, load the seismic and display it. So after displaying in 3D, you have to map out some structures in your seismic. To map that structures, you will need the interpretation window. So to open the interpretation window, you come to the window, then you choose interpretation window. After opening your interpretation window, you take your survey. Now our survey is active and we can either display our seismic in inline or cross line. Literally, when we say we are displaying the seismic in inline, we are trying to say that we are watching the lithology from the top. We are looking, it's like you are standing on top of the rock or the lithology and you are looking down at it. And when you view it in cross line, it's like you are standing beside it and you are looking in the horizontal direction of it. So when I open my inline, this is a typical inline that you can see. So it's like we are viewing from the top. And relatively, inline is good for mapping faults because it is vertical and faults are naturally vertical, not really perpendicular because they have angles and some lithologies have dips. So it is better to watch your faults or to be able to notice your faults in the inline than the cross line. Let me take you to the cross line. This is how the cross line looks like, and it's a bit difficult, though there is a fault here, but it's not easy for you to spot that. There is also a fault here. It's not easy for you to spot that. So in your inline, it is more visible. That tells you that it's better you map your fault in your inline. And for you to know that you are in your inline, you see that all the inline values here are constant and the cross line values varies. Then when you come to your cross line, same thing happens. Your cross line become constant and your inline varies. And cross line is good for mapping horizons. Horizon, mostly what we choose as our horizon is a very bright deflection or a bright amplitude that we choose for our horizon. And mostly our horizons are mostly our reservoir tops. So as we are going to do in IP in the subsequent videos that I'm doing, when you get your reservoir top from the well section, you do something that we call seismic well tie. Then from your well top, you map your horizon. Again, there are some important things that I have to explain here, some important tools. One of these tools is the inspector. So if you want to use the inspector, you choose the cursor, you click on your survey, then you click on your inspector. This inspector allows you to do all the editing that you want to do in this lithology. Whether the color, everything, you can do all your changes and manipulations here. Same way, we have something that we call the player. So in the player, we choose the intersection player. This intersection player is typically the time slider we inserted in 3D. So this time slider changes is our intersection player. This time slide is our intersection player. So what we are trying to do is that we are playing the lithology through so that we see what exactly is happening at each point of the survey. So as I move this, you see the lithology changes. The lithology changes along the time slide. And in our inline, same happens. The lithology changes in our inline. So apart from this, the other features that we're supposed to know are the seismic interpretation menu bar and its tools. So in this seismic interpretation menu bar, instead of going to the inspector, you can use this place to also do your changes and editings. So you can change color here. Somebody like me, when I'm mapping my faults, I change color to white, gray, black. So I look for my white, gray, black, which I choose. So I just change the color here to make it look more visible for me. So you can zoom in and zoom out so that the faults will become more visible for you to see, like how my cursor is moving about. And as I play my time slide, you see the faults changes as the times increases. So thank you for watching this video. In our next video, we will learn how to map faults in our Petrel, and in our subsequent videos we are going to do horizon mapping also. Bye.